This is A.APR.1 Arithmetic with Polynomials 1, Video 3, Finding Special Products of Polynomials. A few terms to know. If you don't already have these copied down in your journal, please do so and define them. All right, in this video we have a few special product rules. We've been dealing with multiplying polynomials, and in some cases we can save ourselves some time with these specific patterns. And the first pattern that we're looking at is the sum of two terms to the second power. And if we were to write this out, it would be the quantity of a plus b multiplied by the quantity of a plus b. And what we have learned up to this point is that you can distribute your terms in the first binomial to each of the terms in the second binomial. So you were distributing it twice, combining like terms, and you came up with this trinomial at the end. Now we have a quick pattern for this, a quick rule. When you have a binomial sum squared, you are going to end up with this given trinomial. You can FOIL it, which I have shown you a little bit about in class, foiling, distributing twice, or in this case, I have come up with this little, I'm not going to call it a song, but a little saying to help you remember this special pattern. So it's called square the first, square the last, multiply and double it. So square the first, square the last, multiply and double it. Now what do I mean by that? If I were to take this first term a, I would square it. If I would take this positive b, I would also square it. Now, the multiplying part are taking your two inside terms and multiplying them. So 1a multiplied by 1b would give you 1ab. And then if I were to double 1ab, it would be that one twice. So I would have 2ab's. So square the first, square the last, multiply them together, and then that answer, double it. And the same would be on the bottom example with the difference. So we have a binomial with a difference and you're squaring it. So if I were to square the first, I would get a squared, square the last. Now that's going to be negative b times negative b. That's going to get you that positive. So square the last. Now if I were to multiply them, that would be 1a times negative b, which is negative 1ab. And then if I were to have two of those, right, I'm going to double that. I would have negative 2ab's. And that's exactly what you see above in this special rule. Now those are going to make more sense as we practice them and talk a little bit more about them later on in this video. But before I get to those examples, I have one more pattern that I want to explain. And this is called the sum and difference pattern. So now, if I'm looking at my product of binomials, a plus b and a minus b, when they are looking similar like that, with the first terms being a and the second terms being b, I have these alternating signs. You're going to notice in the answer, we've eliminated the middle term of our trinomial answer. So if I go back, and let me clear this off here, looking at a binomial product of a square, I'm going to end up with a trinomial answer. Same thing here. I have a binomial squared. I'm going to end up with a trinomial answer. Well, when I have a binomial times a binomial, I usually end up with a trinomial answer. But in this case, you're going to notice I lost the middle term. And why did that happen? Well, when these signs are alternating and these terms are the same, you're going to end up with a zero middle term. Well, let's use the form that we're used to. Let's take that distribution twice. So I'm going to have a, multiply it by a, get an answer. I'll take that a, multiply it by a negative b. I'm going to get an answer. Then we'll take our second term. We're going to distribute twice. I'm going to take a b, I'm going to multiply it by that a, and I'm going to take that b again and multiply it by the negative b. Now if I were to do all the math and put my like terms together, how's this going to look? A squared minus ab plus ab, and then a positive times a negative is a negative. We have b squared. All right, combining like terms, that is why we have lost that middle term. A negative 1ab plus a positive 1ab is a 0. So that's why we have a squared minus b squared as noted right here. So you're losing that middle term with these alternating sum and difference signs. All right, let's go practice. So the first one is a square. This only works with binomials squared. You cannot have an exponent of 3 and have this rule work, and you cannot have a trinomial on the inside and have it squared. So this is a binomial sum to the second power. All right, so square the first, make some room for the middle term, square the last. Well, 8 times 8 is positive 64. So square the first, square the last. Now let's multiply it. Well, that 8 times x is 8x. And if I were to double 8x's, I would have 16x's. Final answer. The second one, square the first. 4y squared. So 4y squared. It's a binomial squared, so I'm going to make some room for that middle term. Now the negative 5 to the second power means negative 5 times negative 5. So square the last would get me a positive 25. Now let's multiply it. Well, that is negative 10y, and if I were to double negative 10y's, I would have another negative 10y, so that's negative 20y. Final answer. Okay, the last one, I have 2 different variables. That'll be okay. Square the first, 9x squared. Make some room. 8y squared is positive 64y squared. And now that multiplication, 8 times 3 is 24xy. If I were to double 24xy's, I would have 48xy's. Just all I need you to do is be careful of your signs in all parts of your trinomial answers. All right, last screen. Let's work with that sum and difference pattern. The first one, I have 3's being in the first slot of my binomials and 1's being in the second slot, and I notice my alternating pattern of signs. So right there, that tells me there's a special rule. So we're going to end up with 9x squared. We've eliminated that middle term because negative 3x and positive 3x, and then we have our last answer. Negative 1 times 1 is negative 1. Final answer. All right, I have a 7 in the first and a W in the second part of the binomials, alternating signs. So we have 49. The middle term is gone, and then negative times positive is a negative W squared. Final answer. All right, last problem of the day. 2a and 2a and 5b and 5b, alternating signs. That means we have 4a squared. We lost the middle term. Positive times negative is a negative. And then we have 25b squared. So we have a difference of 2 squares. Final answer. All right, in your journal, please define the given terms on page 2 of the flip chart. Write a few sentences on what you learned from this video. If you have any questions, bring those to class. This video was primarily made for the fact of practicing special products. If you didn't understand why those patterns worked, bring that question to class and I can answer it for you.